The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Thank you. Let me start by saying this is an extremely difficult task to talk about this in 20 minutes. So what I've done is I've structured this presentation completely different than what I normally would do. I'm going to show some data in the middle based on some student feedback, and I'm going to jump at the end to more of my thoughts, and that's just because I don't know how long it's going to go. And I also, when I give this type of presentation, which is usually to colleagues, Villanova or elsewhere, it promotes a lot of questions, and so I've tried to address some of the common questions, but basically I am an expert in the inverted classroom only because of experience. I have done this, I am doing it, I should say, for the 4th time. Not much in the way of time to go through what an inverted classroom is, but most of you probably have heard about it as a flipped classroom. For whatever reason, I think inverted is a more technical term, so that's the term that I'm going to use. Basic idea is as follows. In a typical in-class lecture, we're going to replace the typical time in an in-class lecture that you think about as me delivering content this way, standing up and talking to you, flipped around with more laboratory and that sort of activity. Outside of class is where we're going to do the me talking to you part, generally through a series of online lectures, video on demand, and there's all kinds of different formats. But the idea is that we're basically going to turn it around and spend most of the time in the classroom working through application, okay, as opposed to talking about theory in a one-way mode. My alternative definition is at the top. This is what I think about. It's basically what's the best way for me to use the time face-to-face in class. That's limited. The other time is limited in some sense too, but there's not the clock on the wall and that sort of thing. That finite amount of time I want to make the best use of. That's what the students are really paying for, the face-to-face time. And how do we structure that? So it's really the value of in-class time. The light bulb moment where this made sense to me was not me seeing some other presentation about this idea. It was probably about 5 years ago, sitting in class, and I was going through, I can't tell you what topic, it was probably, I don't know, shear, something like that. And I remember, you know, the really bright students' eyes starting to glaze over. And you start to think, okay, maybe there's a better way. And I remember distinctly thinking, you see several longhorns in the classroom, I remember thinking about pre-stressed concrete and realizing, long story short, all of us that took pre-stressed concrete with Ned Burns have absolutely nothing to show for it in terms of a notebook of notes. The reality is everybody walked out of that classroom knowing pre-stressed concrete. It's because basically all we did was solve problems. Now, we didn't do it in the classroom. Ned had a way of spending 40 minutes talking about what we were going to do on our own, but the reality is he structured the course about the application. It was not about him standing there and telling us this is how you do pre-stressed concrete. It was about you're going to do it, you're going to figure it out, and I'm here to help you if need be. And so what I did is I kind of thought about it and I realized, you know, that attention span comes from that same thing. So I flipped it around and basically said, let's try to do this. It's 2011, I think, at that point, as this was going on, 2010, 2011. And so I approached it from the idea there's got to be a better way to do this. I listed at the very bottom perceived efficiencies. I mention that because I did not embark on this to try and save my time. And I know this is always, particularly from administrators, one of the key things to think about. We can touch on that a little bit later toward the end of the presentation in terms of my perspective on it. But that was not a motivation, so to speak. Basic idea here, hopefully most of you are familiar with this, but the idea is we're talking about courses that are focused mainly on that application level and below. So things like mechanics, sophomore level mechanics, structural analysis courses, structural design courses. We're not saying that the higher level learning can't occur in those courses at all. But we're saying, you know, the nuts and bolts, so to speak, of what we're trying to achieve is, generally speaking, a very fixed set of specific learning outcomes that we can all pretty much universally agree on. You know, I want to be able to solve an equilibrium problem, that sort of thing. So the courses that I'm focused on here and talking about this are primarily at that level and below. And that's important to understand because by no means do I think the model should be used in the same way in different types of courses. I don't think it would be applicable in a capstone type course in this manner. Certain principles certainly might be adaptable. So these are the 4 courses. And as a point just to clarify, the first place that I used this was in a combined reinforced concrete and structural steel design course 2 years ago, which is a 3-credit course with beyond a lot of material. It's too much. And we knew it was too much. We have since split that off. I'm going to cover the steel design. In fact, I'm covering it now. And a colleague of mine who's actually in the audience is going to cover the reinforced concrete piece next semester. But it's important to note that because there is, I think, some data that is skewed a little bit by just the volume of work built into that class. Bottom line, again, these fit what I talked about, basic application. They're not graduate level courses either, and it's important to think about that. And what do you want somebody out of an undergraduate reinforced concrete design course to have? What do you want them to have at the graduate level? I think they're 2 different things in terms of the level that they should be able to work through. So what we did is we basically look at, this is the old model. I would argue that the primary emphasis, introduction of the application is the homework. There's nothing I can do by saying, okay, I'm going to run through this on PowerPoint. Here's a quick example. I've got 15 minutes. The clock's in the back. Okay, if I decide I'm going to write it on the board and slow the pace down, there's still a finite amount of time. There's not that much I can do. The flipped model simply turns it around and says, I want you to look at the theory outside of class, and then we're going to spend the overwhelming majority of the time in class on the example problems. Now, I call them example problems, but I actually call them problem sets. I kind of blur the lines between what's homework, you know, what are we going to do in class. Sometimes we solve a problem partially, and they finish it. Sometimes there's different branches of a problem with different parameters that different groups of students can look at. Doesn't matter those specifics. The key is that we're talking about, you know, actual calculations. And, you know, generally speaking, I think you can imagine students don't have a hard time paying attention, staying awake, that sort of thing. Usually what we're using is a tablet PC to do this. I call it an electronic overhead projector. Basically the same idea. There's no reason it couldn't be on a blackboard or any format to work through. We generally are talking about most of this is individual students, solving problems individually. Frankly, most of it is them watching me solve it, but at a pace that is much better suited to, let's make sure we've all got it. Hey, what would happen if I changed this? That sort of thing. Okay? Other times, it's group problems. We have things we call overarching problems that we use, different strategies. But the key is that this is the easiest way to kind of phrase it. This is totally an estimate. I do have some time logs and things that I've been collecting, but it's hard to put this up here because it is course specific. So if you think about pre-inversion, I'm going to say, you know, 30 minutes out of that 50-minute period, I probably spent talking like this and telling you, you know, what an over-reinforced beam was and explaining how you were going to go about calculating a certain parameter, but not actually doing it. And then I might have quickly got through and spent 15 minutes or so solving the problem. You can see on the right-hand column, by my estimate, we're close, somewhere 2/3 to 3/4 of the time in the classroom we're actually solving these problems, again in a variety of different formats. Because of the topic today, I thought I'd spend just one slide mentioning how I do the online lectures. First rule is they're entirely theoretical in nature. There are no calculations at all built into it. I talk about the calculations we're going to do, but I don't go through and solve problems. So they're intended to provide the background. We have 2 ways of doing it. We have a pretty extensive online capability in our college that's used primarily for graduate education. I can record lectures there, or lately I've been doing it on my own because I see that you can edit lectures down and get rid of some unnecessary commentary or repetition that you might add. And the students seem to appreciate that, that ability. So they're available basically for them to look at whenever they want between the classes I talk about. It could be on a mobile device. Again, we're not looking at calculations. It's just me talking. I don't care whether they're watching me on the screen. In fact, the latest versions don't actually have me on the screen at all. So what I wanted to do is spend the rest of the time trying to just give you some idea of student feedback from this, and then get into maybe more of the specifics and some questions as to what works and why it does, why it doesn't. So we have a pretty extensive feedback system that let's see, how would I phrase it? It's an anonymous survey, but it's completely mandatory, and it's usually something like it's the last day of class and you can't have your exam back unless you go to the department administrative assistant and hand this in. So there's a way I can collect them and make sure that I've got all the feedback. And we ask a lot of questions, and we provide an opportunity for comments. And I want to read these to you. I know it's me reading the screen, but they just kind of summarize the overall feelings of the students based on this after 3 cycles through now. The fact that more time can be spent with the professors physically working on the problems is more effective than if it were a lecture instead. Helped me see the thought process behind each problem. The setup was a great way to focus on problems. Problems are what we are tested on, and so we should be doing this in class, really prepared for tests. The lectures were not burdensome to watch outside of class, and I don't think I would have been able to complete/understand the homework assignment or be successful on the tests and quizzes. It was also good to look back at the lectures and recorded problems when studying for exams and quizzes. This was one of the things that we almost stumbled into. The last time we did it, we recorded in our mechanics course all of the problems that we solved in class. And, you know, they're short problems. They're not 4 pages long. They're pretty easy. Turned out that was one of the most valuable pieces, according to the students, was the ability to go back and look at those problems, not just the lecture content, but also some of the solved problems. One of my favorites, helps me stay awake in class, unlike lectures. I felt I knew how to do problems by the time I went to do the homework. When tests came around, I barely had to study and still did well because the material stuck from class and homework. I learned a lot in this course from the in-class problems and the take-home problem sets, but the lectures were not at all helpful to my learning in this course. Okay, it's not all great. And there are some realities that are going to be there no matter what you do in any sort of instructional setting. And absolutely the biggest challenge in terms of what most people embarking in this have said is, yeah, but how do you get them to watch the videos? And that's always the kicker. And I would pose the question to you as you think about it. It's taken me a little while to get to this point. But you have to ask yourself what the real value of the videos is anyway. What are you trying to get out of that? And in my case, I feel like it's a preparation for class as we come in. I don't expect them to know everything that I just delivered to them and have them regurgitate it. That's not what you want. You want them to be able to solve the problems as we go through and understand the context of a lot of it. I watched all the videos in the beginning, and then one day I started forgetting more often. Out-of-class lectures were hard to pay attention after 30 minutes, okay, which again helped shorten the videos down. And then the video lectures were helpful, but it was difficult to stay focused on the video outside of the classroom. So again, I don't mean to paint this great picture that every student is going to be responsible and do what you ask of them, but it does seem overwhelmingly to support a more positive outcome. I wanted to focus on the bottom 2 comments here as I try to finish this off. If you look at the next to last comment, I was not a fan at first, but now I'm sold. That usually is the feedback we get from students that have not seen it before. They think that you're requiring them to do a lot more work. That's the first perception. What, you're going to make me watch videos outside of class and then come to class? The reality is, it's no different than me saying, 12 years ago, you need to read this in the textbook and then come to class and do this. Okay? Except I think there's a little better tie-in now. I think there's a little bit more where they can make the adjustment and say, yeah, you know what? As this student said, I get it now. I see where it's valuable. And then finally, I learned more and completed more successful work in this class than any other this semester by far. I think the best way to look at it, though, I think Tyler said we like quantitative type things. So these are the 3 courses. Again, I'm doing the 4th course right now, and I've got, I think, 5 or 6 real quick questions that we asked in addition to all these other things. The format of this course improved my overall learning. Don't think you can ask it more direct. Did the format help your overall learning? And you can see the trend is clearly getting better. A lot of the kinks take some time to work out. Again, we've also, I think, ironed out some of the how much content in a course. But last version 4.6 out of 5. Improved my ability to apply knowledge. Same idea. Last 4.63. Improved my conceptual understanding. We don't just want them to go through and solve the problems. We want them to understand what they're doing and be able to apply it on something else. Absolutely. Getting better. The more through, the more you realize you can do that by the way you structure the problems and how you deliver. Okay? What problems you ask, what format you ask them in, what you ask them to do with those. You can absolutely get some of that higher level thought and the lower level basic knowledge reinforced. Required a substantial more investment of my time. One of my favorites. All right, first time through, oh yeah, this was just way too much. Slower, we're back down, getting a little bit better. And then I think finally, we asked them whether they would prefer this format in other courses. In this course, if you had to do it all over again, would you do it this way? Seems to be yes. Secondly, what about the rest of your courses? Math, science, etc. And it's not nearly as overwhelmingly positive, but it's getting better. My perception of this is that the students realize it depends upon the faculty member to some extent, and that they've had experiences that are good and bad, and they recognize that there are going to be certain thresholds and certain burdens on how the faculty member constructs that particular course such that it comes across well in that particular format. The last thing I want to show you is this slide. This is our student performance for the mechanics course. It's a simple plot. It's a percentile versus final grade. We don't curve anything in our mechanics courses, or at least in this course, it's just a direct grade. It's statics and strength of materials. It's a pretty basic course that we have at almost every university. And if you take a look, the red line is the data that shows that there is some measurable impact. This course could not be a better comparison in terms of we've changed nothing about what we ask in terms of year to year. Okay? The only thing we change are the numerical values on the test problems. So essentially what we've got is a situation where it does reflect in addition in the performance of the students, at least during this course. Post tests have not been done yet or anything to that extent, so we'll see how it filters up. But thank you for your time.